Hey everyone, I hope you did well on your test or your quiz. It was a doozy, I'll tell you. I'm looking forward to grading them though. You guys did a fantastic job reviewing and working hard. So now we're going to start our last section of chapter 6, which is trapezoids and kites. And we're mainly going to focus on the trapezoids today. So let me show you the objective. So we're going to apply properties, so we're going to learn some theorems. We're going to apply properties of trapezoids. And a trapezoid is a quadrilateral with exactly one pair of parallel lines. And we call those pairs of parallel lines the bases. So the bases are parallel, where the legs are not parallel. If the legs of the trapezoid are congruent, then it is an isosceles trapezoid. So if these two legs right here are congruent, then it's going to be an isosceles trapezoid. So you'll need your packet for these next theorems about isosceles trapezoids. So go ahead and take a moment to write this down. So what 6.21 is saying, if a trapezoid is isosceles, then each pair of the base angles is congruent. So G is congruent to H, F is congruent to J. So this is different than the parallelogram. The parallelogram was opposite, but for this one it is going to be each pair of base angles. But that's also true for an isosceles triangle too. So if a trapezoid has one pair of congruent base angles, like here, L and M, then you can assume that it is an isosceles trapezoid, meaning the legs are the same. And if a trapezoid is isosceles, then the diagonals are congruent. So QS is congruent to RT. And if QS is congruent to RT, then you can say it's isosceles. All right, so let's put these properties, these theorems to work. So go ahead and pause the video and draw this picture. So FJH, this angle right here, is going to be 85. And FK is 8. And JG, this whole thing, is 19 inches. 19 inches here. So we want to find FGH. So we want to find this angle right here. So what we know, this is an isosceles trapezoid, so we know that the base angles, both of these, so if this is 85, because they're the base angles, keep in mind here that this is, these two lines are parallel, so this is like a transversal line. So with a transversal line, we have consecutive interior angles. And what do consecutive interior angles equal? That's right, 180. So if this is 85, we can take 180 minus 85, and we get 95. So FGH is 95. Now let's look at KH. This is an isosceles trapezoid, so the diagonals are congruent. So if JG is 19, then FH is 19. So if FK is 8, we can take 19 minus 8, and we'll get 11. So KH, this portion right here, equals 11. Okay? And we're going to continue with coordinate geometry. So if you have graph paper, that would be good to have. ABCD has these vertices. Why don't you go ahead and take a moment to pause the video and write this down. And we're going to decide if it's a trapezoid and if it is an isosceles trapezoid. Okay, so the slopes, we're going to look at the slopes of the bases. because they have to be parallel, so they have to have the same slope. And I gather that a lot of you like counting rather than using the formula because it's quicker. So of BC, let's find the slope of BC. This is pretty easy. We go down 2 and to the right 1. So down 2 to the right 1 is going to be a -2. And AD, can we go down 2 to the right 1? Will that get us there? Let's see, down 2 to the right 1. Hey, what do you know? It is. So we have two parallel lines, just one pair of parallel lines. So we know it is a trapezoid. Okay, we know it's a trapezoid. We can check that off, but now we're going to check if it's an isosceles. So in order to be an isosceles, these have to be, AB has to be congruent to DC. So is it? That's the big question. Well, let's use the distance formula. Some of you also like using the Pythagorean theorem instead. So we have a triangle right here. This is 1 length, and this is 1, 2, 3, 4, 5. So this is 5. So if I take 1 squared plus 5 squared, and I get c squared here, that's going to be the square root of 26, isn't it? Okay, if you solve for c. So that's AB. AB is going to be the square root of 26. Let's see if DC is the same. I'll use a different color here. So can I make a right triangle instead of using the distance formula? That might be better. Let's see. So we have 1, 2, 3. We have 3 squared. So this is 3 right here. And we have 1, 2, 3, 4. This is 4 squared. Let's see what this is going to be. This is 9 plus 16. This is 25. So for DC, C is going to equal 5. So are they the same distance? No. So it's not an isosceles trapezoid. It's just a regular trapezoid. All right. Okay. So I want you guys to go ahead and complete these problems based on the first part of our lesson. Complete these before the beginning of class. I'm going to be checking these before we start our next lesson. All right. If you have any questions, please let me know. You can comment on the page, or you can email me, or just bring questions to class. All right. We will see you guys tomorrow. Have a wonderful day.